Okay, everyone, we're going to go ahead and get started with our final session. So we're doing all things PFAS now, and we're starting this session with a talk by Kelly Kosiarski from Penn State University.
Thank you. Okay. Hi, everyone. I'm really excited to share my work that I did on some PFAS occurrence in private wells. This was a big collaboration with many people, so that's why there's so many authors listed on the PowerPoint. I'm just going to skip this slide. Thankfully, you guys are all very versed in PFAS. So PFAS in drinking water are a concern, especially for private well owners, because there's no federal regulations for private wells, so it's up to the homeowner to ensure their own drinking water safety. And in Pennsylvania, private wells, they make up a big part of drinking water sources. There's over 1 million private wells in PA, and that serves about 3.5 million people. And it's really hard to identify wells that don't meet these EPA drinking water standards because PFAS are not only costly to test for, but they're not noticeable at environmentally relevant concentrations. And I know that there's intent to rescind some of these, but this work was done before that, so all of our exceedances of health-based standards includes all of these. And so PFAS can enter the private wells through many different sources and pathways. They can come from both industrial and agricultural sites. And this is just a map I made of all the potential sources and pathways in Pennsylvania. One time somebody told me it looks like I threw a bunch of Skittles on a map, which kind of is true. But this could be anything from like landfills to manufacturing sites and biosolids application sites. So we had 3 major research questions. One was, what is the extent of PFAS in private wells across PA? 2 was, how do these concentrations fluctuate across multiple sampling periods? And then 3, what factors help explain these levels in the private wells? So we had a citizen science study where we recruited landowners from the Master Well Owner Network. If you don't know what this is, it's just a network of master water quality stewards trained by Penn State Extension. And those are all of the upside-down raindrops on the map. And we had 3 years of sampling efforts from 2021 to 2023, and we had repeats, so people often participated in multiple years, not even because we asked them to, just because they just wanted to know. So the first 2 years, we prioritized counties with a high biosolids application site density because our funding was from the EPA, and then our 3rd year, our funding switched to the Cancer Institute, so we prioritized counties with a high cancer incidence rate. And then we conducted a spatial analysis using both environmental factors and socioeconomic and environmental justice indicators. This is a data set Penn and ViroScreen. It's really helpful, especially because they took down the federal socioeconomic indicator website. And some of the environmental factors we used was land use, soil property, well characteristics, groundwater recharge. So going into the overall detection summary, we found at least 1 PFAS compound in about 65% of the wells, and the concentrations were extremely variable, ranging anywhere from 0.27 to 224.81 nanograms per liter. And about 18% of the wells exceeded one of those health-related standards that I mentioned earlier. And the repeated wells were found to vary significantly from year to year, and I'll talk more about that on the next slide. But you can see here on this map that there is a PFAS hotspot in the southeast of the state. That's where most of the exceedances and the elevated concentrations occurred. So for the resampled wells, in general, PFAS concentrations increased over subsequent sampling years, with an average increase in total PFAS of 9.89 nanograms per liter. And this increase was due to these compounds, and most notably PFOA and PFOS were part of that increase, which is concerning because those are the regulated compounds. And so this is really important context for the homeowners because that may signify that one sample is not enough to determine if your well is safe to drink and meets drinking water standards. And we tried to tease out the reasoning for this, but we didn't have enough information. So we looked at rainfall, but we didn't have groundwater pumping or flow or elevation data at all. So we were only able to look at rainfall for this, and it did not explain it very well. Going into some of the environmental factors, the most consistent, significant predictor we found was the influence of developed land. So this is a map of a county level summary of the percentage of developed land. The darker green represents areas with higher percentage of developed land. And you can see it often coincides with wells that had higher PFAS. So this is likely from the influence of population density, increased human activity, septic systems, and industrial sites. We also saw an association with cropland, just for PFBA, which is a short chain, more mobile compound, and PFOA, which is that legacy compound. And we weren't able to tease out what the sources could be. It could be from pesticides, compost, biosolids, a bunch of different things. And so for the influence of soil properties, we found that soils with a higher percentage of sand often had higher groundwater concentrations, which could signify that sandy soils are not as good at holding on to those PFAS, so they drain faster into the groundwater. And then organic carbon, we found a negative association with just one compound, and organic carbon has been shown to increase the absorption of PFAS, so it could be that it's helping to retain this compound. And same with cation exchange capacity. We found a negative association with one compound, but higher CEC may reduce absorption. So for well characteristics, we found only significant relationships with well age, and we found that older wells often had higher PFOS. This is not clear why. It could be from the drilling oils. It could also be from, over time, the well deterioration if the homeowner isn't taking care of the well casings and things. But we didn't find anything with well depth or groundwater recharge, even though that we know deeper wells may be less vulnerable, and we know that high recharge may dilute PFAS. Going into some of our socioeconomic factor results. For poverty, this was counterintuitive at first, but it makes sense, but after I'll explain it, higher PFAS were found in wealthier areas, and we looked at the distribution of our participants, and we saw that we didn't have a good representation of low poverty areas. So most of our samples are from areas with very low poverty. And with race, we found that there was higher PFPEA, which is a short chain, and higher PFOA in areas with a higher percentage of non-white populations. However, same thing with poverty, we didn't have a good representation of areas with a high percentage of non-white populations. So this is like information we'll hopefully use for our next sampling campaign to have more intentional recruiting. And for cancer incidence, it was extremely difficult to even look at this because cancer incidence is just extremely complex. And so the correlations didn't really show anything. This is just a map of cancer incidence throughout the state. I did see a paper just come out that took into account like people moving, which I think is a massive factor. You can't just look at cancer incidence, you have to look at where they grew up and stuff too. So when we looked at the interactions between the environmental and socioeconomic factors, we found that there was a positive association between cropland and pesticide density, and a positive association with pesticide density and PFOA. This could be a potential source of PFOA. And then we found that poverty and developed land were negatively correlated, which could explain the reason why developed areas had higher PFAS, because developed areas often have lower poverty. And then so some of our key takeaways and future research directions, we found that developed land was the most consistent environmental driver, but we need to look at the impact of septic tanks. That was a massive factor we were not able to consider in our study, and we know that it impacts groundwater concentrations, especially in private wells. And the socioeconomic patterns that we observed in our study found disparities in exposure and potential gaps in our voluntary monitoring that we did. And so we may need to do broader, more equitable outreach to improve the representation in the private well testing efforts. And then we turned all of this into a county level map. We also combined it with public sampling data from the Pennsylvania Department of Environmental Protection. This is just a tool for people so they could look at their county and try and make informed decisions on what kind of samples have been taken in their county and if they want to test their water. Thank you.
Hi, so one thing that I'm actually kind of curious about, I know Pennsylvania doesn't have a well code.
Yeah.
So I'm kind of curious if, the potential impacts of there not being a standard for how wells are dug could potentially have an impact on how PFAS could potentially be getting into wells.
Yeah, I think that is a really good question, and I tried to talk about that when I wrote this paper, but I just didn't have the information on the well construction methods that these homeowners use, because some of them had moved there, some of them got new wells built. It wasn't clear, but I would love to also, if other states are doing similar studies, I'd love to compare with their well codes and see if we're finding differences.
Mm-hmm. Thank you.
So some of this is making a connection. with septic tanks, because I see that was in your closing slide. One thing that I've seen that I actually think is I would encourage like looking at with any. I've looked at a lot of large private well data sets. Massachusetts is the first state I've seen talk about this, but a key metric for private well contamination that they've nailed down is septic density. So it gets at the same. It's kind of getting at the same idea of the developed counties you were looking at, but it's even zooming in a little bit. And there's not good data sets on septic density necessarily, but you can take municipal sewer supply areas and then use E911 addresses and assume everywhere where there's a registered residential address that's not in a municipal sewer supply, that is that. You can use those points as a measure of septic density, and you'll have these hotspots show up like mobile home parks, where you'll have really dense addresses, and then you'll find out they're either on their own septics or they're on a shared community septic. But it's just the same idea of like, every person in society has a PFAS load associated with their waste stream. So that septic density is a kind of a key metric, which would be really cool to look at for a data set. And then for the socioeconomic thing, there are some sewer shed level sampling that's happening right now in different areas, and they're finding something similar where there's higher PFAS loads coming from residential neighborhoods that are higher socioeconomic status versus neighborhoods from lower. And it's so there's.
Do you know what state this is happening in?
I can share some stuff with you.
Great.
So it's happening in areas where there's wastewater treatment plants are getting it out of their effluent, and they're sort of trying to characterize their sewer sheds. So there's some in Minnesota, there's some in that I've seen in Vermont and some northeastern states.
Okay, that's really interesting. Thank you so much.
Did you investigate whether any of these well owners were using their well water as their primary drinking water source? And if so, do you guys have any follow-up on treatment?
So all of the participants used their well water as a drinking water source, and I think about half of them had some sort of treatment. But we actually asked them to sample pre-treatment so we could see the raw water. So we didn't follow up post-treatment, but it would be interesting to compare the raw water with their finished water.
I have one online. What was the LOD of your instrument for PFAS?
It varied per compound, but some compounds get as low as 0.05 nanograms per liter.
Hi, thanks for your talk. I have two questions, actually. One is I'm very impressed by everyone who does citizen science because I'm a control freak. And I was just curious what kind of instructions you gave your citizen scientists in the collection process, and if you had any sort of QC or statistical cross-checks throughout your sample to see if there was like variation in human sampler. And then my second question is, it seems like most of your results are correlations, and I was wondering if you had any future plans to develop a more robust statistical model, like a GLM or something like that, a multi-level model to sort of parse out more of an effect as opposed to just a correlation of what's driving your contamination.
Thank you for your questions. For the first one, I already forgot. Oh, okay, yes. Oh, so actually a really big advantage to using the Master Well Owner Network is they were already trained to sample. So they already know basic sampling, and then for the additional PFAS contamination, we just provided very clear instructions on like what products not to apply, like right before you sample, and like we gave them gloves, and we provided shipping containers for them. So basically everything was standardized for the sampling. And then we also had them take field blanks, and all of the field blanks came back non-detect. So it was really good news. And then the second question, these stats are based on a Tobit regression that I ran. It's, I don't know if you're familiar with Tobit, but it can handle sensor data. So instead of replacing like the non-detects with half the detection limit, it just can use maximum likelihood estimation to kind of map that distribution. So I didn't actually put any of the effect sizes because it's really hard to get a model that meets all the assumptions. So I just relied mainly on if it was a positive or negative, and then if it was statistically significant, although some of the factors showed way more effect sizes than, like way higher effect sizes than others. Yep.
Based off of your Skittles map, where you had all of the potential causes. I'm just curious, those wells that had an exceptionally high amount of PFAS, were you able to draw any conclusions or make any correlations there specifically about what could have led to those sites specifically having such a high concentration?
That's a really good question, and I actually looked into it a lot. I tried to look at a 5-kilometer buffer and how many point sources are in the 5-kilometer buffer. I tried to look at distance to closest point source. I tried to rank them and weight them differently. I found nothing. Yeah, it was not clear based on if you're closest to a point source, if you're going to have higher concentrations or not. It was mainly developed land and population density.